question 9. Okay, so let's move this question to a whiteboard. And we'll start on that, please. Okay, a curve is such that dy dx is given like this, and P15 is a point on the curve. Okay, the first part they say, okay, so I'm just going to copy that dy dx statement, which is equals to 12 over 2x plus 1 whole thing square. And then they give the point P15 is on the curve. I'll just keep that in mind. So let's do the first part, please. So they say the normal to the curve at P crosses the x-axis at Q. So find the coordinates of Q. So you're talking about the normal. So there is this theory. First, we must understand some background knowledge, which is that whenever you have, what do we say, a tangent line, let's say it's a tangent line, and then the normal line is defined for that point, let's say in the point of a curve. Sorry, I didn't draw the curve. Okay, let's say I just whack the curve like this, not just a curve, because the definition is with respect to a curve. So just a point in interest now. So the normal is a line that goes through the same point. All three of this line and this curve all go through the same point, but the normal has a gradient which is perpendicular 90 degrees to the tangent. So this is the general visual representation. Okay. Okay, the normal to the curve crosses the x-axis. That means what I'm trying to say is, and the tangent is linked to the dy dx, not the other things. So for the curve, this is the function of y equals to fx, or fx itself. And the tangent is its gradient is how it's linked to the dy dx of that curve. Can you see the link? So the dy dx is the gradient function. We say it's a function when it has more than one value, so it varies according to x as it goes along the different coordinates. So this is the link. That means then we have to link the gradient to the gradient of the normal. Okay, that will come to that in a while. So that means what I'm trying to do is the normal to the curve at P. So this is the given point. So at P, I just copy the x equal to 1 part and I evaluate the dy dx. That means this dy dx, when you evaluate it at 1, so it becomes 2 plus 1 square, blah, blah, blah. So 12 over 9, right? So 12 over 9 is, when you reduce it, this right is an improper fraction, 4 over 3. This is the gradient of the tangent. Okay, so now we know this is gradient of tangent. So we can just call it like, let's say M1. And then the gradient of the normal, let's say the normal has gradient value of M2. Now there's another theory in coordinate geometry. This is how they're linking few things, as you can see. So M1 times M2, whenever the lines are perpendicular, then the product of the gradients is -1. Okay. So when the distinct lines are perpendicular, we have this, the perpendicular part gives this relationship. So therefore, that means using this, we can just easily substitute now. Oh, that means this is 4 over 3. This part is M2, and this part is -1. So in other words, the gradient M2 of the normal is -3 over 4. So this is how this whole information is just for us to calculate first the normal, the gradient of the normal. Okay, how do we do the next point, please? Okay, the normal to the curve crosses the x-axis at Q, they say. So how are we going to even determine that? It's that by determining the equation of the normal. So let's go for the equation of normal, please. So what is this equation of the normal curve? So equation of normal curve, let's just say it's a straight line. So we use the general form y equals mx plus c. So I just substitute the -3 over 4, m2 in this case. So if you want to put m2, so can, x, so can, as long as you put the right number, plus c. So we need to determine the value of c first before we can get. So it goes through the point. Remember the point in concern is the same point P. P is 1, 5. So I'm just introducing the point when we use it. So 1, 5 like that. So that means this tells me the value of x is 1, y is 5. So 5 equals to, -3 over 4 times 1 plus c. Oh, so then by solving that, so we get 5 plus 3 over 4, which should be, the c is 5.75. So I'm just going to write it in the decimal form. C is 5.75. It's okay. Okay, so c is 5.75 means then the equation becomes what? So the given equation is from here. Let's go ahead with that. So y equals to -3 over 4x plus 5.75. Okay, now how do you find the coordinates of Q? So we go back to the definition of the point Q, crosses the x-axis at Q. So when you cut the x-axis at Q, that means the y coordinate is 0. So it's something like x0. It's also known as another word for it is x-intercept. Okay, in some places they call it the x-intercept. So to determine the x-intercept, the y is 0. That's the key. Oh, so just put y 0 lah and solve for x. They put this 0. So negative 304x plus 5.75. Okay, it's just simple, what we say, algebra lah. Okay, bring the other side, change it to decimal. Since I wrote the other side as decimal, it doesn't matter. So 5.75 either way, divide by 0.75. Okay, let's calculate that, please. Aha, then we get a nice fraction answer, I guess. This time I'm going to write it as a mixed number. So the coordinates of Q will be, because this becomes 7203, one last part. So Q having the coordinates of 7203 and 0. Okay, it's good to keep it in the fraction form sometimes to make it look nice like that. Okay, so that's how we find the coordinates of Q. All right. Okay, let's clear this 7203 and this. Okay, so let's go for the second part, which is, let's clear that. Aha. The equation 7203. Let me just write that. Sorry, don't forget 203 and 0. Okay. Now, find the equation of the curve. So how do we figure this out? The equation of a curve is a bit more tricky. Okay, so how do you find this one? Let's begin. Let's calculate a few parts and see. So the equation of the curve is we must do the antiderivative, or in other words, from the dy dx is equal to, let's rewrite the dy dx in the exponent form, because the formulas of integration and devising are in exponent form, so easier to write in exponent form if you can do anything. Okay, so the inverse, so that means just, what I mean is just integrate this. Okay, please integrate that like that, dy negative 2, power of negative 2 dx. So when you do this, the constant term, just remove it outside, no effect on that. So there is a trick you can employ actually before I do that. So if it is in the form like when you differentiate the inside, which is 2, and you get a 2 there, that means I can just rewrite it like that. Put a 2 in front because of easy differentiation. The trick I think you should be familiar with. It's like something like this. So the idea is that when you go to f prime x, and then here it's like fx, means the function is inside the bracket, power of n dx generally. Okay, so what happens is when you integrate that, it becomes like something like fx. You just add the power 1. Okay, because the differentiation, so you just need to divide by the n plus 1 only, because the differentiate inside is already in front. So differentiate inside here is a constant, because differentiate 2x is 2. 6 times 2 is 12. So I can employ this shortcut. So it makes things easy. And if you do rewrite, divide by 2, so it doesn't matter. 4 times 2. So in this case, it becomes, then the fx is inside. So becomes 2x plus 1. So negative 2 plus 1, negative, let me show that ones, sorry. Negative 2 plus 1. And then you divide by that, negative 2 plus 1. So now we realize that we have to actually put a plus c, sorry. Almost missed that. Okay, plus c. And then we get all y equals to negative 6 to then over 2x plus 1 power of 1. So this leave is 2x plus 1 plus c. Let's take note. If my calculations are correct, let's double check, please. Plus 1 divided by 1. Negative 1, negative 6. Yep. Yeah, that's correct. Okay, this is the equation for y. Okay, being that said now, how do we find the equation of the curve? We use the same point P. Can you see that? So P is x 1, 5. Means also the point lies in the curve. That's why we must use this point, not Q. Q is not a point on the curve. So let's substitute that, please, to determine the value of C. So then this becomes minus 6 over 2 something plus 1. part plus c. Yeah? So that means what I'm trying to say is this is the 1. X is 1. We substitute like that. Okay, let's try to solve it and see what happens. So 5 equals to, this is 2 plus 1, 3. 6 over 3, negative 2 plus c. So therefore, we get the value of c as 7. So if c is 7, then what happens is we rewrite this or just substitute. Bingo. We finally get the equation of the curve as y equals to negative 6 over, just for the sake of the negative sign, I put a bracket. But it doesn't matter. Even if you didn't put a bracket, we can write it like this. In this case, it's nothing ambiguous. 2x plus 1 plus 7 or 7 minus that. Okay, thank you. Okay, we're going to reconnect before we do the third part, because the time is less than 1 minute, so it looks like we got to break it up to that part.